So hello everyone. Today we've got a functional series, and what we want to do is, what we have to do here is we have to prove that this series converges uniformly by using the Weierstrass criterion for uniform convergence, which states that if given a functional series and if its general member is always less than or equal to the general member of some numeric series which is convergent, then the given functional series is uniformly convergent. Okay, so how do we go about doing that? So first of all, let's say that f of x is equal to x times the square root of n times e to the negative n to the fourth power x to the squared power, x to the second power. Okay, now we want to find the maximum of this function first. We want to express x in terms of n such that this function has the greatest possible value. Okay, so f of x is equal to the square root of n, I'll just factor it out since it's a constant, of x times this, so that's just e to the negative n fourth x squared plus x times e to the negative n to the fourth x squared and times negative 2 x n to the fourth power. Okay, now we can rewrite this as the square root of n. And I'll just go ahead and factor this here part out, times e to the power of n to the negative n to the fourth times x squared, which just leaves us with 1 minus 2x squared n to the fourth power. And finally, we can rewrite this as the square root of n, e to the negative n to the fourth, x to the second, and this is of course the difference of two squares, 1 minus the square root of 2 xn squared times 1 plus the square root of 2 xn squared. Okay, now this part is always going to be positive. And let's find the zeros of these two parts. So from the first part, we get that square root of xn squared is equal to 1, or in other words, x is equal to 1 over n squared times the square root of 2, or when we rationalize it, the square root of 2 over 2n squared. And from the second one, we get that square root of 2 times xn squared is equal to negative 1, from where it follows that x is equal to negative 1 over n squared times the square root of 2, which is equal to the negative square root of 2 over 2n squared. Okay, now let's go ahead and draw a value. So we've got two stationary points, but let's go ahead and draw a table to see whether these stationary points are minima or maxima. Okay, So 1, 2, whoop. So okay, so here we've got negative infinity. Here we've got negative square root of 2 over 2n squared. Here we've got positive square root of 2 over 2n squared. And here we've got positive infinity. Here we've got 1 minus the square root of 2 xn squared. Its 0 is this. And here we've got 1 plus the square root of 2 xn squared. Its 0 is this. Here we've got f prime of x, and here we've got f of x. Okay, so since we've got a negative in front of the x here, it's going to be positive before it's 0, and then after that it's going to be negative. Now here it's going to be negative, and then afterwards it's going to be positive. Okay, so that means that f prime of x is negative here, positive here, and negative here. So that means that the function is dropping, then it's rising, and then it's finally dropping. So that means that f of x has a maximum at x is equal to square root of 2 over 2n squared. So when a function is rising up to a point and then immediately falling down, getting smaller and smaller after that point, that means falling down, I mean descending. That means that it has a maximum at that point. So let's just go ahead, and now that we know this, let's plug this in to our original f of x. So x times the square root of n. So f of x, and I can put it down max, is equal to x, but instead of x I'm just going to put down the square root of 2 over 2n squared times the square root of n times e to the negative n to the 4th power times x squared, which is just 1 over 2n to the 4th times 1 over 2n to the 4th power. Okay, so when we rewrite this, so, and this is now actually f of, well, it's now actually f of n. So these two very nicely cancel out, and we can rewrite this as e to the power of negative 1/2, which is just the same as 1 over the square root of e times 1 over the square root of 2 times n squared, which is the same as n to the power of 4 over 2 times n to the power of 3 over 2. Okay, so that means that now we've got a numeric series as n goes from 1 to infinity of 1 over the square root of 2e times 1 of n to the power of 3 over 2. Okay, and now we can just go ahead and factor out the constant. And we're left with this series. Okay, and we know that this series converges. Why? Because it's a hyperharmonic series. So, hyperharmonic series is a series with form of n equals to sum n 0 to infinity of 1 over n to the power of alpha, and it always converges. So it always converges for alpha is greater than 1, and it is greater than 1 in this case. So we know that this series converges, and we know that it's always greater than this here series. Okay, so therefore this series must converge uniformly. So since this series converges and 1 over the square root of 2e times n to the 3 over 2 is always greater than x times the square root of n e to the negative power of n over 4x squared, we conclude by using the Weierstrass criterion for uniform convergence that this series converges uniformly. So that is our final answer for this video. So I hope you understood the video. I hope it was interesting. If so, leave a like button and subscribe. Leave a like and subscribe. I'll see you in the next one, and goodbye.